Hello, everyone. Thanks for joining us today, wherever you are around the world. My name is Josh Benwell from the Eplan Customer Journey Team, and welcome to the webcast Utilizing Calculations in Your Design. This session is being recorded, by the way. It's going to be sent to you tomorrow. And if you have any questions throughout, please leave those in the chat, and we will get to those later on in the webcast. Okay. Again, my name is Josh, and I will introduce you to one of the smartest people that I know. Wait, the smartest person I know isn't on this call, but
Oh, there,
uh,
yeah, I was going to say I was confused. I thought someone else was joining us.
I want to bring in our expert here at ePlan, Ian Underhill. Ian, kind of tell us, take us through how long you've been with ePlan and what your role is.
I've been with ePlan 7.5 years now, something like that. And I'm a consultant. I work out the Farmington Hills office, which is a suburb of Detroit, for those that don't know. So a lot of auto industry around me, obviously. What was the big three? So that dominates the sort of customers I have around in this neighborhood. But yeah, I do training, I do things like this, I do demos, pre-sales, coaching, all
You
sorts of
do
stuff.
webcasts whenever I make you.
Pretty much, yeah, pretty much.
Well, this is an important topic for us, utilizing calculations with design. I know that you and I had a chance to talk a lot about it in the weeks prior to getting this webcast on. I'm going to go ahead and let you take it away and run with it and present.
Okay, okay. So I'll share my screen. Give me a second. Let's go find up the right
I know we're on
one.
GoToWebinar now, so this is a little bit of an
Yeah, this
adjustment from
yeah
before.
this is a new thing. This one is. So share
We
screen.
already got a comment saying this is really fancy.
So I guess it's going to go with that one. So hopefully you can see my screen now.
Yes, sir.
Okay, that's a good start. So this is just a little project. There's actually only 2 pages in it. One page that's important is the one we've got at the moment. This isn't meant to be instructional on how to put this together, just to give you an idea of potentially what the properties or what the possibilities are. It's quite a powerful tool. Block properties have been around for as long as I can remember with ePlan. It's just a part of the tools that you have available. What's new for 2024, I believe it was, is the ability to do calculations with them. So when we're talking about block properties, what are they? So there's a couple of different styles. So my colleague David did a little thing about block properties, the block party, I think you called it at
Yeah,
the
yeah, we
time.
had a little
Yeah,
block party. That was
yeah,
over a year ago now. We had a block party.
yes, it was. So David discussed there's a couple of different ways to describe block properties. So again, without getting too much of an instructional video, we can have block properties that are local to an actual device itself. So in that case, any property that's related to the device, in this case the motor circuit protector, we can go get those properties. We can also go indirect. So an indirect property would be from this device here, we can travel along any of the connections that join this device to another to get the properties of the item at the other end. So in this case, what I'm quickly going to do is just look at finding information about this motor at this motor overload switch here. So let's go into the properties here. And actually, let me move it so hopefully you can see what's going on. So when we go to the block properties, you need to display them so you have access to them. And any block properties we're looking at here are related to this particular device. To make things easier, you can add block property here. So we've got two things: the format, i.e., what block property information we're looking for, and then the result of that search is in the block property, and each device has 100 block properties. So we can see it easier rather than just adding them to this big list. I've actually made a little scheme, so we can look at the in this case 3 block properties that are important to me for this. So the first thing I'm going to do is I want to travel along the wire here to this device, the motor, and pull the full load current from the motor. So I'm going to go into my device. And see, at the moment, we can tell where we are by the function. So we're in this motor overload number 0135. So from the motor overload, I want to travel to this motor. So I go to this last connection via connection point. And you need to pay attention when you're doing this. If we look at the first connection point, that was connection point 1 on the circuit breaker, it takes me to the different motor. So that's not where we want to go. We want to go connection point number 2. And we want to go to the target there, which we can see is this motor, MTR 0135. This is this one. So to get there, we use the stairs here, stair icon. And when I click the icon, it tells me now where I'm located, where I've gone. And if we look up here, we see I'm now at that motor. So once I'm at the motor, I'm going to look at the part, the actual part that we've selected. So here's the part information. And it's part number 1. There's the part number for the motor. Now I can select the property from that part information. And if I scroll down here, we see here's the current that's stored there, 1.9 amps. So current there. So if I select this one, I select OK, and then I do the apply, we can see now that's the property I'm looking for. This is the result of that search. So we can do things like here, we could probably add a block property to say, let's just use a separator, and I can add set MCP at. So I can add a separator, then I can add my block property here. So general functions, and there's the block property, and we see the setting. So now I can read the motor and have a piece of information I could display here somewhere. You see here, it says set most circuit protector at 1.9. So those are a couple of properties I can put together, and I can do that for each one of the motor circuit protectors I have here, and also this device. So I could go through each of these and do the same thing. So, but the other part of the block properties is, yes, they can be local or, direct or indirect, as David would call them, but they can also be local or global across the whole of the project. So if I, for example, if I take this block property, I'm just going to copy it and go into my properties for my project here. And again, I've set up a scheme to make it easy. I'm going to paste that one in there, and I've also got one that I prepared earlier to make it easier. So here I'm looking at properties, block properties for general devices, things like motor overloads, motors, just general items fall in that general devices selection. So if I select that now, and let's go back. We will see I can delete the properties from here, so I don't need them locally anymore because it's reading them as you see, for each of these now is displaying the same information. As it happens, they're all the same size motor. So now we want to do some calculations. So, and again, when I'm doing this, I would typically go to one device at a time and store check the property that it works, and then maybe if I can put it in the global properties. The reason you put it in the global properties for the project just makes life easier. You don't have to go to every device and check that you've added the property. So again, here, what I would like to do, I'm going to add up the amount of current drawn by each of the devices. Then at the disconnect, I'm going to have a total load. So how am I going to do that? So I'm going to start at the end. I'm going to take the value and add it to the previous value. So there's no previous value here. So for this one, in this block property, I'm just going to go to the block property here and let's get the one from block property number 8. And I'm going to change this in a minute. So I should have shown you. So now I've got 1.9 in block property 10. So here's the calculation. So here, I want to add the current block property to the block property 10 of the previous device. So add them one by one. So I'm going to go and do a calculation. And the calculation is first, I need a property. And that's the block property of my current device. Make it a little bit bigger so we can see. And let's see, the nice thing about this version of Eplan is actually you can see what the value is, so I can see that. And then I'm going to add it, so basic maths. And now I'm going to add the property of a previous device. So select the plus, and I'm now back into that same idea. So this time, now I need to go back to a previous device. So I'm going to go connection via target number, and this time I'm going to use a target number 1. And here we can see I can go back from where I am to the previous device. So I'm going to go back to there. And once I'm at that device, then I'm going to again look at, so you can see I'm at overload, excuse me, overload 135. I'll go to the main, let's go to the main function. And I'm going to go to the block property, general function, block property 10, previous one. So I'm going to add these two together. And again, I'm just going to copy and paste it from the one I did earlier, so I don't have to go through this over and over again. So I'm going to just select that and paste that in there. Apply. And so we see we've got the addition. But again, rather than just have it local here, I preferred it to be in the block properties for the project as a whole. So again, I know that it works. Let's delete that. I'm going to go in the block properties here. So now, for every particular device, here it says this is the local, this is the sum. It's the last one, so it's 1.9. This is the sum. So it's the last one, it's 3.8, and so on again. So when I get to here, 5.9, and even though it's a completely different device, it still counts as a, excuse me, a general device. So even this has the information up to add it all up. So now this is the last device, and I'm now going to come to my main disconnect. For this one, I'm going to put the properties in here local, because this is an unusual one. It's slightly different to the previous ones. So in my disconnect, all I want to do is look at the not the properties to add them up. I just want to look at the previous device. So again, I'm going to do some formatting. I'm going to do this in block property 10, which I haven't got in my little list here. 10. So to explain what I've done here, again, it's a calculation. So let's go and have a look at what I've got. I've looked at the total connected load by looking at that previous device, the most circuit protector. Then I've looked at this concurrency factor, and this one's an interesting one. I'm going to show you a better example of how you can find properties that maybe are not easily accessible. So this block property 1 I've got, I set it up in advance for this. Let's see if it's showing it in there. Block property format 1. So I wanted a block property that if I was looking for it would not typically be available. So I want to go to my project, and I wanted to find an environmental one. And sometimes you can't find those properties. So this is a neat little trick. Now I can check the property name. So I'm going to just randomly pick a property. So I'll pick this one. And I can see here that this is the property name there, 101. And then I can go to my project, and I'm going to look for the thermal category, thermal design. So if you find out what the property name is, I've just done a reset, so it's not showing my settings. But you find out the property name. Bear with me a second. Oh. I've got to do a setting. I do apologize for this. Here's can't find my property. Can't find the one. Anyway, I won't chase that one down. I know that the name of the property I'm looking for is property 10312. So I can just change this manually like that, and I can now access a property that I wouldn't normally be able to. So that's a little trick. I'll show you that again in a second. So with that one, I've got this concurrency factor, how many items are running at the same time, and then I've done a simple calculation to see if 90% of the items are running, then my continuous load is going to be 7.83 amps. And let's just show that works. So Let's change my size of my motor. Let's pick a 10 amp motor. So it's now 13.3 amps. You see it's automatically updated that here. Just do a quick update of my connections, and now you see it's now added that value up. So a comparatively simple tool just to add up the loads.
Yeah, it seems really simple to someone who doesn't do this from my standpoint over here.
It's the tool, the sort of possibilities that are available with this tool are sort of endless. You just got to think. A lot of people come. Maybe we could do short circuit calculations. The key thing about doing any calculation is to make sure you've got the data. Without the right data, it's you can't work. That's why Eplan is so important, because of the data that we have available, and then obviously the access to that data. So you've got to check that the data is consistent. And when you're doing these types of calculations, try and make the block properties more global, because then you don't have to go and check each one. If you've checked manually, as I've just done here, it's easy to check that it works, then move them to the global block properties. So you don't need to type them in. If I bring another device in, because it's a general device, those properties are still going to apply to it. I don't need to remember to add them in, because if you've got to remember, there's a chance to forget, isn't there? But key thing is you've got to check that the data is good. So things like doing short circuit calculations, the data, you're going to need to add a lot of that, because the manufacturers, because you can use a device, this motor overload could be used in a 480 volt, and it's going to have a certain rating for short circuit. For example, if you're using a 208 volt three-phase system, it's going to have a different rating. So you've got to pay attention to that data, make sure that your data is consistent and consistently in the same location for all of the devices that you're going to want to do calculations on.
We are taking questions, by the way. We have quite a few questions that we've gathered so far. So if you want to leave those, we can get those answered. Are you ready for questions, Ian?
Let's go with the questions.
Yeah, let's get to some questions now. The first question is it possible to create a one-line diagram with devices and have the SCCR calculated by Eplan?
Yes, absolutely. Just as you can, I don't have a one-line diagram here, but just as you can do the connections from device to device. Maybe in terms of the SCCR, that would be an easier way, because there's only one connection point. So absolutely, yes, you can. But again, it's all about the data. If I look at the particular information from this device, and this is from Bradley, and to be fair, they're quite reasonable at having the information, but they can't give me, it's a standard capacity break-in, but they can't give me, for example, if you wanted to put the value in there as a switching current, a switching capacity, that if that's where you wanted to store the value, they can't give you that data, because it depends how you are using it. So you need to be quite thoughtful about what data are you using, because this part can be used in 400 volts, 480 volts. It's rated, I think it's rated up to 600 volts. So it can be used in loads of different places, but depending on that voltage that you're using it in, what the rating would be. So again, be quite careful about when you're picking a piece of data to use, that the data is going to be consistent for you, because if it's not consistent, then you're going to have use bad data that give you a bad result. So the answer is yes, but as they say, pay attention. And there's an example of how you could find, if you couldn't access that property, there's the property name there. 22072. So if you can't access it directly, now this one I'm pretty sure you can, but if it doesn't appear on your list, if you find a similar one, and you can swap the property out. So the current, for example, is 2071. So if I couldn't find that, that's how I would change the property name.
All right, next
Long-winded
question.
answer to a short question, eh?
Yeah. How can you catch an error? Say the block property finds zeros or find zero values.
Again, that's one of the things when I'm putting them together, that I would do it much more on a local basis rather than the global basis, the property-wide basis, because and display them. So when I was doing this, as you see, I was having an error, but one of the things I did was I put a display together that showed the properties. And I can. So in this case, I had properties 6 and 7. So I put the properties together. So it's worked out the conductivity, it's got the resistance. So I can see at the moment, obviously I've got a problem. It's displaying the volt drop as being 0. So I've got a problem with my accessing of data, or getting the right data. So add displays. You can make them so they're invisible. So if you want, you can make so that could appear all the time, but I could change the value of that in terms of the display, so that normally it would be invisible. So let's make both of those invisible. So normally it's not there, but while I'm going through the check-in procedure, I can turn the U key on and I can see them. So that allows me to, I don't have to go back and change them. So yeah, add displays so that you can actually look and check your calculations. I also did a little spreadsheet, an Excel spreadsheet, when I put the calculations together, and again check the results when I entered the values I expected, that I got the results I expected in my spreadsheet, and then compared them with the results I was seeing in my Eplan calculations. It's all about checking and making sure the data is good, until you're confident over a number of different applications you're getting good data.
All right, up next is if I switch an item out, does this then break the link?
It depends on the item that you're switching out. So for example, when I was with this calculation, when I had it working earlier today, before I broke it, when you change the cable out, so for example, if I took the cable here, and I can briefly show that. So I go to the cable. If I pick a different cable part, so I'm going to pick a it's currently got a 16 gauge. So let's go to 14 gauge. Let's go to a 16 gauge. So if I do an update, sometimes you'll see that you'll lose the connections. So in this case, when I changed the cable, one of the things I had to pay attention to was to go to the cable and make sure. I'm going to show you. So let's change that again. So 16 gauge. Let's go to the 14. So you see the links are broken here. You can see in my cable navigator, the links between the functions and the placement is broken. If I do an update, so it can break those links. So just pay attention. In this case, I do a reassign all, and then I know that the value that I got was good. So just pay attention if you make changes, you do an update, update your your connections and just check. And then that's probably another reason why you should maybe keep the display. It's very easy. You can just press the U key on your keyboard, display the results of the calculations, and you can quickly identify, hopefully, where if you've got an error.
This next question is one that you might have to look at the question yourself, Ian, just because you'll see that the way it reads out from Christian. It says, "Is there a way to make the global block property format more readable? So instead of having the less than 2021 comma, you make it block property 10, and it's just more. It's easier to read from that point."
I don't know whether there's an easier way, and that's sort of the problem, because when you're talking about the block properties in a global, uh, let's look at demo block properties here. It, there's no way to have. So here we've just purely got the format in. There's no way to see what the display is, because it's for all sorts of devices. So it can't say, well, give me the value for a particular one to make sure it's okay, because it's for all devices when we're looking at it in this instance. So I don't know whether there's an easy way to do that, and that's in part why when I'm doing these things, that I would do them locally first, make sure I know what I'm getting, and try it in a few places. So yeah, I can see that I'm getting the right result, and then copy those to the global settings, remembering that if you've got a local setting here, that overrides the global settings. So you have to go then through one by one, deleting them. And as you delete them, just make sure that the values you're seeing don't change. If they do change, then obviously you've got an issue. So you need to check what you've done in the global properties. Maybe you've mistyped or misconnected, or sometimes it can even be, when you're looking at traveling down from device to device to device, you can add a connection into a particular device, and that becomes the first connections, and therefore what was connection one that you were thinking of now is connection two. So you've tracked off in a different direction. That's something that you find when people try and do it with like network diagrams, or connections from black boxes. If you show a black box, two parts of a same device in two different places, when you've only shown one part of the black box that maybe has two connections, there be connections one and two. When you show the next part, and it might be a page before, a page after, they might be another two connections, but because of the naming of them, they may become alphabetically connections one and two, and the first ones you placed are now three and four. So when you go to connection point one to go and look for something, it's now looking in a different place than you expected it to. So be aware of those. It's something GM, I do a lot of work with General Motors, and they do a lot of those block properties to find information about on the network drawings. And until you put all the different parts of a device, the order of the connections isn't the finalized order. So when you go down to connection one, it might not be quite what you expect. So yeah, it involves quite a bit of testing and thinking about the end result, and what you're putting in. It is yeah, not necessarily a simple task, but it is powerful.
All right, we have a few more questions, and I want to try to get to all of these if possible, or as many as we can.
Yeah, for sure.
So earlier you showed block property 10, and it works whenever your T node is the direction that you had it. But to make the process wiring work, the T node has to be pointed up. How would you suggest calculating the total load with also allowing the process wiring module also give the correct wire length.
Yeah, I mean that's a. I hadn't thought about that in terms of how I would tackle it, but it's a very valid point. These are daisy chained together, as the user has just said, by virtue of the fact that the way the T node goes. So the T node, for those that are not familiar, this would say that the wire comes down, goes into this device, and then back out to the next device. So I know that directional flow works. So in this instance, it works no problems. If these were all pointing back to the one device, so they were like T nodes that look like that one, for example. So this T node indicates that there's a wire from the disconnect to here, and then another wire that goes to the next device. So this would break. I'm pretty sure if I do an update now, this is probably going to break. Yeah, see, it's broken because it's now is not including this in the additions. So it's a valid point that needs addressing. Do I have a solution? No, because I haven't felt the need to do it in this one. If I was using, for example, a distribution block here, then maybe the calculations have got to be all in here. Makes it a little bit more complicated. So it possibly involves more thought about how you're doing that if you're using a different style of connections.
Well, the good thing about this is that Sean Mulheron is watching this, and he
Yeah.
brings these kind of topics back to our headquarters, and whenever we have the different platforms for each year. So you got somebody on your side that's watching this right now. That
oh yeah, yeah. Well,
yeah.
someone give me a round of message. No, Sean's very knowledgeable, and it's as I keep saying, it's very, very powerful, but you've got to pay attention to what you're doing and how you're doing it.
Yeah.
So that you make sure you get a consistent result. And this is just one example, particularly when you're going from device to device in terms of getting the data. Now, maybe more useful would be to bring all the data back to the devices and then maybe pull some reports or have a calculations separate where you could pull the devices, regardless, rather than calculating it here, some other method of pulling them all together. It's just you have to think about that when you're putting these together. It's not necessarily a moment's work.
All right, we're going to fast track some of these. When calculating the loads, can you make it ignore the motor overload on one branch and instead go to the motor to find load?
So read that to me again to make sure I'm understanding.
When calculating the loads, can you make it ignore the motor overload on one branch and instead go to the motor to find load?
Well, in each case, the only time I've had to do something like that was where I had a VFD. In the example I've got, rather than a motor, I had a VFD in between the overload and the motor. In which case, the VFD became the last device in the list, so I went to that device rather than the motor. In the same way as here, this power supply is the last device, so it pulls the information from this power supply. But that's if it was a one-off basis. So, for example, if this one here I wanted to pull the data directly from that, then I could put some local block property here, and whereas all the other ones are going the normal way that I've decided, this one I could make different. but again, the problem is you want to be consistent, because and if you're doing the same thing over and over again, you can keep checking it. But if you add an oddball in, you need to remember where that one is, and it's got the potential to, if someone say copies that, use it somewhere else and doesn't realize what's happening, you have the potential to break your calculations. So
Okay. Can you have predefined variables linked to blocks to have the drawing calculate the same data we are seeing here automatically?
predefined I guess you could use custom or user properties to have those, to create constants, predefined variables. I guess I'd need to know a little bit more about what, rather than just waffling on and not hitting the question exactly. If I had more information about an example, so I could understand what the question was.
Yeah, so we can, this is also something that we're going to do. Any of the questions that we don't get to by the end of this webcast, that we are going to be reaching out and answering these. So we'll email you and contact you in person to give you more information about the questions that you have about this. So don't worry if we haven't nailed it down completely right now, that we will be following up. So definitely don't worry about that. Can I apply calculations to macro projects?
Yes. Well, I guess, if I remember that's what I'm looking for. Remember what it's called. Okay. Yes, you can. So if I think what we're talking about here, so let's go back home. Right, tags. Let's throw this one in here. So I think in this case, as you see, I had those properties pre-built into the macro for this particular device, because that's the way I started doing it, rather than doing it in a global version. So yes, you can have properties built into a macro, or calculations built into a macro that act on the information in that macro, or potentially, as in this case, it acts on the information that it expects to see for devices that it thinks is going to be connected to. So this motor here circuit, I worked out what these calculations were, or what the values I wanted to look for in here, then copied the circuit, put it in my macro project, and obviously those block property formats went with it. So yeah, if I understood the question correctly, yes, you can.
That's the easy answer, right?
Yes.
Next question. Can you create warnings if values exceed other components' ratings?
So the way I try to do this in, when it was working with my volt drop, the way I used the warnings was, I created excuse me, a comparison. So you can't do if and then. All you can do is a comparison value, and I think, let's go and have a quick look in one property. So you can do, if I do a calculation, you can do comparison functions. So for this, like for example, greater than or equals, or something like that. So for example, with the volt drop, typically if the voltage drop is greater than 3% of the voltage, so 480, whatever 3% of 480 would be. If the value is greater than that, then that's an error. When you do a comparison like that, all you get is a true or a false. So a 0 or a 1. So 0 being false, 1 being true. So for in that instance, what I did with that, once I created the block property with that comparison, then I did a text exchange based on the true or false. So although it's not working, I can I can show you that. So So there's a category for the where is it here? The replacement text. So I think I put it in 20, which is displayed here somewhere. Just got to find it. Replacement text here. That one. So what I did was, if the value is 1, I did the comparison to looking if the value was greater than the 3% that I calculated, then I said, right, the volt drop is going to be excessive, and that's going to display. If it's less than, don't display anything. So that's the way I sort of highlighted an error by using the value. So in this display, this property would display, and I made sure it was bright red and large. So if that was true, so that's the way I tackled it. I think David does something similar with his block property. With
Okay.
that, I did the same. Also, think one of the things that makes things like the calculation of the volt drop a little more difficult is the fact that we've got here in the States, we don't use SI units. All the calculations you probably read are based on SI units. So the one that I read for the volt drop was based on conductivity, which is in Siemens, and the square cross-sectional area of the cable, which is a meter squared, not AWG. So again, I used that replacement text to read the value of the cable, so 14 AWG, and I replaced that value with 2.08, whatever it is, for 14 gauge is the square millimeters, and then did a calculation on that to get to square meters. So you can use, that's a useful tool, using that text exchange or text replacement.
Awesome. Some great questions, and we have quite a few more that we won't be able to get to all of them today. But what we're going to do is we're going to follow up all the questions that I have that have accumulated. We will be reaching out and we'll answer these one by one with you. So don't worry about that if you didn't get your question on here today, or Ian didn't answer it just yet. Ian, great job. Thanks so much. Block properties. I will say this, that if you want some other information and besides what you've seen here, that if you go to our YouTube channel, that you'll see David Ridgel did the block property. We had a block party just a little over a year ago, and we did a webcast. So you can check that one out on our YouTube channel. Not only that, but our next webcast is going to be on February 20th with Paul Galiniak. Covering automating panel design with automatic routing. So you can discover how to modernize your panel design process with automatic routing, experience a fully digital workflow from design to production. And so what that entails is whenever you do automatic routing, you can dramatically reduce design time and errors, optimize wire utilization and panel space, increase accuracy with proper wiring size and fill rates, and lastly, I say lastly, there's more than this, but enhance safety and compliance with adhering to industry regulations. So
Sounds
I'm
like
going to
you
go
should have
ahead.
started telling about this earlier.
Yeah. I'm going to go ahead and leave this in the chat. This is the registration for the next one. and that's going to be again on February 20th with Paul Galeniak. So for today, thank you so much for joining us. We really appreciate it. We're going to have more of these. We're going to have monthly webcasts for you to give out just some good information that you might want to hear about using ePlan with our experts. Ian, as always, you're the best.
Yeah.
All right. Thanks, everybody, for joining us. We'll see you for the next one next month with Paul Galeniak on February 20th. Have a great week.